Aloha, Richard Halverson here, and today I'm going to show you how to do, help you do quiz 14.7. So let me share my screen. And this is the one here. And we're continuing with dictionaries and lists and sets and how to use them. And so it's the end of the chapter. And the first, let's go through this. First question is given a dictionary D and a list LST, remove all elements from the dictionary whose key is an element of LST. If there's any of them that are not elements, then you're supposed to add them to a set called not found. So we have an example here of a dictionary and a list. And so in the list is 1, 6, and 7. So we're supposed to go through here and remove 1, 6, or 7. But if one of them is not there, one or more of them is not there, we add it to this set here. So 1 is there, 6 is not here, key value 6 is not here, 7 is here. So 1 and 2 are removed, 7 and 8 are removed. That leaves 3 and 5. And then since there was no 6, that gets added to this. And so not found is going to contain 6. All right, so let's see. What do I have here? This is blank. Let's just put dictionary D here. D equals that. And list is going to be this. Copy. LST equals that. And we have a set called not found. Not found, and that's a set. This is how you declare a set. And I'm going to go for item in list for each one of those. First, I want to see if it's in D. If I is in D, then I want to remove it. How do I do that again? Delete D of I. Yeah. Otherwise, if it's not in D, then I will be wanting to add it to the not found set. So not found, add I. So let's see what this looks like. So then, so I'm going to test this, and the first thing I'm going to do is I'm going to print D, and then I'm going to print not found set. Okay, so let's see what this looks like when I run it. Okay, 3, 4, that's this. 5, 6, and what's left is the set. Not found equals 6, it looks like. So that looks pretty good. So now you know how to do it, and you should be able to answer this question. All right, what's next? Given a set called weights and an integer called desired weight, remove the element of the set that is closest to but not greater than the desired weight, and associate it with the variable called actual weight. All right, so basically we have some weights, and we want to pick and then we have a desired weight, and we want to pick the closest weight, uh, to the desired weight, but not going over it. Okay, so in this case, 19 won't do because that's over 18, but so it's going to be 14. Because 14 is the closest weight to the desired weight without going over. All right, so let's just start over. And I'm going to have a variable dictionary called, no, a list called weights, a set called weights. And that's going to look like that. And I'm going to have something called a desired weight. And I'm going to output an actual weight. So so I'm going to want to loop through okay, how do I okay, so I'm going to use in set functions, there's, min, max, len, all those same functions that there are with all the other, list type structures, lists and dictionaries and so on. So I'm going to initialize actual weight, and the smallest that it would ever be would be the minimum weight in weights. Okay, so I'm just gonna initialize it at that because it's got to have a value, and it's not going to be smaller than that. And then I'm going to go up the for W in sorted. I'm going to use this sorted function that's available for these kinds of data structures, weights. So for all of the sorted, so this is going to go through all the weights, and each one is going to be called W, and it's going to be in the sorted order. So the first one, it'll be 6, and then it'll try 7, and then it'll go 14, and so on. And each time, if W is less than or equal to the desired weight, then I want to set the actual weight equal to the desired weight, or equal to W, not to W, because that's a candidate to pull out and to take. And I'm going to go up as close as I can until I finally go over. And then if I go over, I'm going to exit out of the loop. So actual weight will still be equal to the last one that was a valid one. So this is a valid candidate. So I'm going to set actual weight to that. And remember, I'm actually looking at these weights one at a time in sorted order. So I'm starting with 6, then it'll be 7, then it'll be 14, then 19, then, no, I forgot 12. Okay, 6, 7, 12, 14, 19, and 22. So that's going up like that. So if the weight we just looked at is less than or equal to the desired weight, then it's a candidate. Otherwise, it's going to be greater than, and we want to exit out of the loop. I break, I think that's how you exit out of the loop. So let's print. We're supposed to pull out anything, or we're supposed to pull out? We're supposed to pull out the actual weight then. So that would be weights remove actual weight. Okay. And so I think this is the code that you want to probably paste in there, but let's print this out to see what it looks like. Print weights. Print weights. Print actual equals actual weight, and then weights equals weights. Okay, let's just see what it looks like. Uh, 14, okay, 14 is the one we pull out, and so that one is pulled out, and that's the closest to the desired weight. All right, okay, that's question 2. Let's see what's next. All right, assume we have 2 lists, list 1 and list 2, and they are the same length, and we're going to create a dictionary that maps each element of list 1 to the corresponding element of list 2. So in other words, we're going to create a dictionary, and the keys, and it's like these 2 lists are kind of like in order, and the list 1 is going to be like the key values, and list 2 is going to be like the value values. Okay, so that's you have a dictionary, you got to initialize the dictionary, then you're just going to go the range of length of list 1, and it's going to be the same for list 2. And then you're just going to set the dictionary one of, the first one, I, equal to whatever the second one is. Okay, but does this work? I don't know. This might not work. Okay, you could be off by 1 because of the indexing and so on. But anyway. Yeah, that's not how the book does it, but I think what I showed you will work. Okay, so here we're going to make a dictionary that maps the first n counting numbers to their squares. So in other words, it's going to look something like, squares one squared equals 1. Squares 2 squared equals 4. Squares 3 equals 9. Then 4 equals 16, and so on. See, these are squares going up, and it's the first n. So if n equals 5, then we go up to 5. Okay, so it's something like that we're making. Well, that's the same thing as this other one that we had before, the last one, where we're going to have a 4. See, first we have to initialize squares. Squares equals that, and then we're going to do something like 4i in range of n. Squares of I equals I times I, or I, or you can do I I think that works or something. But anyway, so it's going to be something like this, but this doesn't quite work. Okay, it's because of how it starts out and everything. But the idea is there, and you just need to do what I showed you on the previous on the whiteboard. All right. So this one here is okay. So you have this variable called election results, and it's associated with a dictionary that maps the candidate names to how many votes they got. And so you're supposed to, you know, so you have this dictionary, and you want to associate the name of the candidate with the, so then you want to assign a variable called winner. You want to assign that the name of the person that got the most votes. So if we look at something like hawaii.gov/elections, and look at the last election here. Let's look at the results, and let's pick some race that's not that controversial. About District 2 representative. Can I make this bigger? Okay, some of you might have voted in this election with Kai Kahele and these other people, and they were going for Tulsi Gabbard's job. Tulsi Gabbard retired, and so we can. So if we have a election results equals, and I'm just going to go a curly brace and a curly brace. I'm going to paste this in here and see if I can turn this into something. I'm going to do double equals. These are all the people that ran, and this is how many votes they got. Oh, I guess we can leave Kai's name there. Quote, comma. And then these, I got to close the, oh, I don't need that. Got to get rid of these commas. And comma. Okay, that looks pretty good. I'm going to sort this just so it doesn't give away who's the. Can I sort this? Oh, I don't know if I can sort with this editor. I guess not. Settings, language. Some editors, there's a, you can just sort. I guess not. Okay. Anyway, all right, that's fine. Okay, so this is our dictionary. We got names and number of votes. Ooh, this is should be colon, 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 colon. Okay, that's better. And then we're going to have, by the way, the parties are down here if you're ever interested. Libertarian, Green, Democratic, Nonpartisan, American Shopping, Constitution, Republican, and Aloha Aina. Okay, so we're here, and we have this variable called winner. And we can put, so we have a winner. And that's not equal to anybody. Let's just, Let's just set the, okay, so this is going to be someone's name. So let's just set it to the max name, max of election results. And this is not going to be the maximum number. This is going to be the highest in the alphabet because it's the key. So this is probably going to equal Tippins, Michelle Tippins. Okay, so that's what's going to default to, but it's okay because we're going to go through all of them for each candidate in election results. And so these are going to be the key values. If election results of the candidate is greater than is greater than election results of what we have as the winner, which might not be the winner because we're still going through it. If a candidate that we're looking at is bigger than what we have as the winner, then we have a new winner. So winner equals candidate. And that's about it. When this thing goes all the way through, at the end, winner is going to equal what the winner is, and so we can just print winner. And we can also print what the result is. Election results. Winner. That'll be the winning amount. That'll be this amount here. So we can save this and run this and see what this looks like. Oh, this is not, it doesn't like this. How about this? Okay. So yes, it prints out the name and the number of votes that person got. And of course, Kai Kahele won that race. All right. Okay, so the last one, we have a variable called D, a dictionary called D, and you're just supposed to create the inverse of D. This question is exactly the same as quiz question 14.6.18, a video that I just made. So why don't you try to do this on your own? Okay. So anyway, that takes care of 14.7, the 14.7 quiz. And so I hope this helps. Thanks for watching.